We are proud to launch Medikabazaar Talks, an exclusive healthcare-specific knowledge-sharing and conversation platform, powered by us to facilitate a deeper understanding of the entire healthcare domain, be it challenges, opportunities, past lessons or future endeavors. Our vision with this platform is to cover most important topics regarding the industry, and then gradually zoom out to create an entire knowledge warehouse. This knowledge management platform will be built on strong, tested and implementable opinions from esteemed experts of the industry. We will be conducting regular sessions in the form of webinars, expert talks sessions, CMEs, CXO meets and more where industry leaders rich in experience can share their diverse and deep knowledge for the benefit of the entire community. Thanks for tuning in. Hope you would find this interesting and insightful.
And as it applies to both radiology and pathology. So, Dr. Sethi, thank you so much for joining us today. I know you're teaching, several classes, and that you had to move some of them around to attend this webinar today. So, really grateful and thankful for that. And last, but definitely not the least on the panel is Dr. Harsh Mahajan. Also happens to be my dad, who is the founder and chief radiologist of Mahajan Imaging. He is a Padam Shri awardee and serves as the radiologist to the President of India. But I think most importantly, he also serves as the chief annotation officer of Caring, which basically means that he's the person who is often found marking up scans. And I'm sure Dr. Amit will have lots to share with Dr. Mahajan on that front as well. And we'll talk more about what we mean by annotation and why it's such a critical piece of the puzzle of AI today. But without further ado, thank you so much once again for joining. And I'd request Mr. Joy Chakrabarti to share his thoughts on the subject as the keynote speaker for the next 10-15 minutes, and then we can dive further into the panel discussion. Thank you. Just one caveat, sorry, just one thing I wanted to say before we start. Please feel free to ask questions. The idea behind this is to make it as much of a dialogue as possible, as is possible in this virtual domain. So use the chat box, use the messaging service. Feel free to ask whatever questions you'd like, and then during the course of the discussion, I'll try my best to address all of them. We have already sought permission from CII to run over 1 p.m. deadline by 15, 20, 30 minutes, as long as it takes. So feel free to ask any questions that you may have. So without further ado, Mr. Joy Chakrabarti, the floor is yours.
Thank you, Dr. Vidur, and thanks for moderating this very important session for us. Very happy and pleased to see Dr. Harsh Mahajan has joined, like a expert in this field, not only in the imaging but also in the healthcare in India. Then Mr. Amit, Dr. Amit Kharad, Dr. Amit Shetty, my good friend Rahil is also present, and I welcome you all of you in this session on behalf of CII, on my personal behalf. I just wanted to add that in the end of this month, from 24th, CII Western Region is hosting a 15 days virtual exhibition and 4 days conference on digital health, application of digital technology in healthcare. So this is the prelude for that, and we are trying to get experts to come and sit together and share their thoughts. And I'm very privileged to get all of you in this session today. Now, when Vidur asked me to give a keynote on AI and ML in radiology imaging, I find it extremely difficult and feel humble to talk on the subject when so many of you are there as an expert. But I can tell you, as a healthcare provider, when I run a hospital, I want to tell you that today, maybe some of us are privileged to have qualified radiologists, our experts in our panel, but you need to understand that in India, if you need to reach out to the poor and the rural folks, you may not have qualified radiologist who can identify the right information from the image, the interpretation of that in the proper way. So that leads to a situation when we need to apply technology. So one thing is where you don't have support and help from the experts easily available, you can explore. At the same time, if you are looking at the volume, the kind of work we are going to do, if we need to increase, then we need to take help from this artificial intelligence to get a quick, breakthrough that what it is and how. So that is the other reason why we need to apply this. But I'm sure apart from this, a lot of research work, a lot of advancement in terms of diagnosis, early diagnosis can happen through this artificial intelligence, machine learning, through all these methods. Let me tell you, this artificial intelligence came in, first in Western world just to ensure to meet the requirement that how many samples, how many reports, X-ray, films, and all, how soon that can be reported. But in Indian context, it is little different. It goes in terms of huge volume and shortage of experts. But I look at it, the kind of artificial intelligence work has been done in identifying some of the, not only in the imaging, but also in ophthalmology, diagnostics for retinal dysfunction. Some of the applications have happened in other specialty area. Those are really mind-boggling. So one of those areas in imaging is going to be addressed today in this session. So I'm sure the audience, they are going to get a lot of valued inputs from the participants, and most importantly, you are going to get the valued inputs from the dons of this field. So without further ado, I hand over to Dr. Vidur, and please take this session forward. Thank you.
Thank you, Joy sir. Thank you so much. I will be asking you questions as well as we proceed with the next, 1 hour or so. So let's jump right into the discussion. And typically professors are used to being the ones asking questions. So I will cold call upon Dr. Amit Sethi. So Amit sir, what is AI? What is ML? What is DL? And why is it all so suddenly it's come into our lives and everything is now AI? What's the background and what's the difference between all of these things and what's different today?
Sure, sure. So AI.
I think Amit sir, could you repeat that last sentence? Yeah, I think seems to be some network issue.
Hello.
Yeah, we can hear you now, sir.
Hello.
We can hear you.
Yeah. Okay. Great. Great. Sorry, I had to switch network. My other network was not very good. Am I audible now? Okay.
Yes.
So the way I think about AI, machine learning, deep learning is the following, right? AI is a catch-all term for anything that is intelligent, any software that exhibits intelligent behavior, right? So if we are thinking of a very simple algorithm, such as you have a set of numbers, you have to sort them in increasing order. It seems like there is not much intelligence to it. It is also an algorithm. But let's say if you have an algorithm that has to find the best path between your source and the destination, then it can be thought as a little bit more intelligent than that. But within this set of intelligent algorithms, right, there is a set of algorithms that thrive on data. That the algorithm itself is derived from data. You don't pre-think of the algorithm. The data tells you what the algorithm should be, and it is still a very complicated algorithm. And that is what machine learning is all about. So I wouldn't be a professor if I don't talk in terms of formulas, but I don't want to scare the audience. Am I still audible?
Yeah, very much.
Okay. So if you think
Although
about,
I was
let's say,
tempted to say that you're not, because you were going to start talking about formulas, but still.
so let's say we have a formula to rank order students, right? So
Yes.
we rank them based on their university marks, based on their high school marks, and so forth and so forth. And we plug that into a formula, and that gives us some predictor of how successful they will be in their job. And obviously, just the university marks are not enough. There might be other hidden factors such as what their leaders, what that leadership skills shown in sports. Did they, head a cricket team or a football team and so forth, right? So all these factors you plug it in into a formula, and that predicts whether the student, once they become a professional, whether he or she will be successful in his or her job, right? So that could be a formula. Now the problem is that what is the individual, sports leadership, of their school marks, of their college marks, that we may not know, beforehand. So what we do is we look at retrospective data. We see that, let's look at everyone who has been successful and unsuccessful in their jobs, or relatively less successful in their jobs. Let's look at all their past data and organize that data into well structured variables, that and then let's look at that and then see how do we separate those who did well in their job versus those who didn't. So that is basically an example of statistical analysis, and then if you make it more complicated, it becomes machine learning. So the difference between statistics and machine learning would be that in statistics, the formulas are more rigorous claims about those formulas. In machine learning, the formulas are more complicated, and in deep learning, they become very, very complicated. But you cannot make theoretical claims about how these about the applicability of these formulas. You have to actually test them in the field, and only the field will tell you whether your formula is applicable to an unseen data. So your formula is, if it cannot predict anything, if it cannot predict on new students, so we want to be able to predict that coming out, predict what their job success will be in the next 5 years, and that could be for different jobs. Now the problem, this leads to several issues also.
No, go ahead, sir, please.
You train the formula on students from University of Delhi, and the marking scheme of University of Hyderabad is like, so has a bias towards mostly students from University of Delhi, because it only saw those students when it was doing the modeling. So then basically you have to think about how those biases come into your new data when you start to expand the application of your model into new domains, into new data cohorts and so forth. So the difference between, I hope that this gives you an idea of what machine learning is. Deep learning is just basically a much more complex set of formulas for machine learning, which are specifically applicable to one type of or couple of types of data, which is imaging data and text data, and things associated similar to that, like audio data and video data.
So, Amit sir, if I was to, try to simplify this into a couple of statements, would it be right to say that, number one, to do AI today, we really don't need to, at least superficially, we don't need to know the math behind it, because the computer does the math itself, right? And hence, that's the dangerous part also, because with the computer doing math, you don't know, like you gave this beautiful example of Delhi University students, and you're developing, some concept that, okay, English marks are a driver of future success. And let's say in Hyderabad, English is not a subject altogether. Or, so you'll have to figure out different metrics, different horses for different courses, and something like that. So that's the inherent danger with some of this. And I'm sure as we dive deeper into the clinical side of things, some of these questions would emerge. But thank you so much for that introduction, and basically, laying the ground, saying that everything is statistics at the end of the day. It's just how you do it. Next, I'd like to ask Dr. Mahajan, so why AI? Why is AI in medical imaging becoming such a such a hot topic of discussion nowadays, and why not other fields of medicine? Why medical imaging specifically, and subsequently, what are some of the market sizes? The way you think about the evolution of AI in imaging. Dad, if you could share your thoughts. I think you're on mute. You're on mute.
Sorry.
Yeah.
The major reason why, imaging and radiology has been at the very forefront of artificial intelligence, development of algorithms, is because the data is all digital. That is the primary mover for this, that you already have things which are digitized, radiologists are used to it, our equipments are available, the data can be transferred, and then it can be collated, and it can be sent anywhere in the world and be looked at. So otherwise, if it were something written on case sheets, it becomes so very difficult to put it together. How do you do it? You will first have to digitize it before using it here. And also the fact that it's all DICOM data as far as images go. So what I have here in India is what they have in the US or anywhere else in the world. So that really is the prime reason. Two, the data is humongous. It is, if you want 100,000 X-rays or 100,000 CT scans of a particular disease or a particular type, those can be available because you can collaborate across the globe to get that all together. Point number three, radiologists have also been used to this kind of using this data and writing their report. And PACS systems, picture archival systems, have been around for at least 2 decades. And even in our country, in India, we've had them for about 10, 12 years. And so the data is available. Then using it, it can be used for actually by these healthcare companies, the manufacturers of MRIs, CTs, and all that at the back end to do the math, as has been just very beautifully elucidated by Ahmed. And so that mathematical data is easier to for AI algorithms to use and develop for image processing, for improving the image quality. And then for us as radiologists, two areas where we need help. One, in getting our measurements done, which have to be done manually, knowing what is the volume of a lesion, knowing the size of a lesion. It is a very tedious job. Say multiple lesions in the lung or in the brain, to count the number of lesions, and over time to see how they are changing, we need help. At times, for a case of multiple sclerosis in the brain, which has 50 lesions, and then you do a follow-up scan, which may have some lesions which have disappeared, some new lesions which have come, it can take me hours to do a good quality report. That's where we need help. And then we know globally there's a shortage of radiologists, and especially more of quality radiologists. And that's where, again, if we had a tool which could read the X-rays or the CT or the MRI automatically, that would be a great help. It could be a pre-read. Even if a AI algorithm were to go to a chest X-ray and say that so many are normal and so many are abnormal, that would be a great help. And that's where it can be useful, and more so in the underserved parts of the world where there are no radiologists, where the scan is being read by someone who's not a qualified radiologist. It would be helpful for even that person, be it a physician or a surgeon or a cardiologist, to have a pre-read helped by artificial intelligence algorithm, which can help him in making his final decision. So that's why the initial, emphasis on radiology and imaging. Now, what is the market size? The market size is humongous. If I were just to take the example of a chest X-ray, a chest X-ray is a very simple thing for anyone to do. It's ubiquitous. It's present. It can be done any and everywhere. Also, for a radiologist, it's the toughest to read because there are so many variables in it. But if we were just to take this simple chest X-ray and see what is the market size, it is said that about 2 billion chest X-rays are done every year in the world. And this is a figure which is about 2 years old, but let's stick to that. And let's say, look at the United States of America, because that's where most of the imaging gets done, and say that 25% of all chest X-rays are done in the US. That's 500 million chest X-rays done in the US every year. And that's a low number, but let's take it as the gospel. Now, in the US, a radiologist charges anywhere between 10 to 50 US dollars to write a report. That's apart from getting the chest X-ray done, and all of that. Just for the reading part, anywhere between 10 US dollars, which is what the government insurance company pays, to about a 50 US dollars. Let's take it that it's 20 US dollars on an average. So multiply 500 million into 20, and you get an astronomical figure. If I'm not wrong, that's $10 billion just for reading of chest X-rays in the US. And now suppose Amit were to develop an algorithm which does one simple thing: tells whether a chest X-ray is normal or abnormal, doesn't do a deep dive into what the abnormality is. And we know at least 50 to 60% of all chest X-rays that are done in the world are normal. So let's say that figure is 50. And let's say out of that 500 million, 250 million X-rays are normal. And suppose someone who's developed this algorithm were to charge $1 for the read to differentiate normal from abnormal, he will make $500 million. But look at what he'll save if his algorithm was good for the entire healthcare system. $500 million against $10 billion, and half the chest X-rays now don't need to be read. So that's $5 billion worth of read that has been done in $250 million. So the healthcare system, with just this simple algorithm, will end up saving $4.75 billion. And this is just one chest X-ray. And for the more complex investigations, for the more complex algorithms, it could be anything. So that's the scale of savings. That's the scale of the industry in absolute terms that we are talking about. And so the scale is humongous. Apart from all the obvious filling in of the resource crunch that exists in many parts of the world. I hope I've answered your question.
Yeah, no, absolutely. So I think, quick one-line summary again is that, standardization of medical data to whatever extent, we are still always, aspiring for even more standardization, but at least, as you beautifully mentioned, the DICOM standard exists, and, all CT, X-ray images at least look similar and are stored in similar mechanisms. Which allows the unleashing of these algorithms. And then, of course, the market opportunity is possibly as huge as the entire medical imaging market itself.
So if I may just conclude, the end result of all of this, if we were to able to build robust algorithms which work, which are accurate, is one. Radiologists will get better because they will be helped by these AI algorithms, become more accurate, and be able to do higher turnover of cases. Two, you will be able to use it in underserved parts of the world. And three, overall, as the example I gave you, it will it will lead to reduction of healthcare costs in the
Yeah.
realm of radiology and imaging. And so you will improve access and you will improve affordability.
Yeah. So no, thank you. And Rahil, I think that's a great segue for you to chip in. You know, I've seen your lab and I've seen, the amazing robots and, all of those arms doing everything that, typically in a non-mechanized lab would not be as, am I audible? Sorry.
Yeah, you are.
Yeah, sorry. So I've seen those robots, I've seen all of that automation, and how do you see what is your wish list, right? How do you see things that are maybe sometimes obvious in lab medicine, translating to the world of radiology and imaging? How will AI play a part? What do you wish you had in imaging that maybe you already have in lab medicine?
Thanks, Vidur, and good morning to everyone. I was just thinking earlier today, and I said, when I was thinking about a wish list that I want from my radiologist, and maybe I will present a little bit of a different perspective coming from a management perspective as opposed to a clinician or a radiologist perspective. And I thought, but at the end of the day, our our vision and wish is very simple, and I'm sure all radiology practices will agree with this, that we want the highest quality of reporting in the shortest possible time with
Yeah.
optimal communication to the patient and the referring clinician. Sounds very easy, and yet often it's just a utopian vision that doesn't translate into reality. Somehow, I can see Amit smiling. Amit reports our MSK studies at Sancheti Hospital in Pune, and he will agree that somehow this doesn't always translate into reality. All three elements of our wish list don't come together: best quality, shortest time, and optimal communication. So really, we would like for AI to bring in all these elements on a consistent basis, day in and day out, within radiology practices. And it's being done in lab medicine, like you mentioned, Vidur.
Yeah.
And that's our aim for our radiology practice and for radiology practices in the country. Now, um, while I agree with Dr. Mahajan that typically radiology is amenable to AI because radiologists are used to working with electronic images, DICOM data, and so on. At the same time, radiologists, like most doctors, are very difficult people to deal with. They don't like to change. Uh, you know, there are a few exceptions like Dr. Mahajan, Amit, who are very keen to adopt technology and learn new ways of reporting. But most people are very set in their old age ways of thinking and what they've been exposed to in their training, and they don't want to change. So typically, if you see healthcare and radiology, we've been slow adopters of IT. You look at other industries, radiology is lagged behind. Within medicine as well, pathology is far ahead of radiology. So why is that? I think one of the
Yeah.
challenges also is that within radiology, we have disparate, disconnected systems. So everyone is working on their own independent platforms, and there's really no common platform on where all radiology practices or medical data can come together. So that's another issue that needs to be looked at for wide scale implementation of AI. So my realistic expectations from AI into a practice like ours would be, one, like Dr. Mahajan mentioned, automate a lot of the routine time consuming tasks, whether it be measurements in cross section, in ultrasound. These are not productive tasks for a radiologist to be performing day in and day out. Can normal studies be auto released? I know Amit is doing some very exciting work on that front with chest X-rays. Can they be released like we do in pathology, where only abnormal studies get flagged and normal studies are auto validated and auto released?
Yep.
The other area I would like to look at from AI is assistance with structured reports. So we see a lot of variation from radiologist to radiologist in their reporting language, in the reporting structure, in the reporting format. Can AI help to clean up all of that and ensure that from the same practice, at every point in time, a similar looking report goes out to the clinician? and also if it can help in cleaning out the report so that it's easy to follow in a nice tabular form, and not wordy and verbose like a lot of radiology reports are given presently. Um, a lot of radiology and imaging is now going to move towards quantitative medicine as well. So that's another area I thought where AI can play a role in quantifying findings. So if we look at dementia, for example, as quantification comes into brain volume and so on, can we remove subjectivity of a radiologist in performing those quantification analysis, and can AI enable those so that irrespective of who's reporting, we still get the same form of quantification from patient to patient. And the last piece was on assistance with identification of abnormalities. So it becomes an assistant tool for a radiologist for peer review as well as differential diagnosis while looking at complex studies like chest CT scans, for example, where if a nodule is missed, AI may suggest additional findings, which the radiologist is then free to choose whether to accept or not. And when I look at laboratory medicine, so before I come to the lab, one last point on that front, I think that I've seen Vidur develop a fantastic platform where all these AI apps exist on one portal. It's almost like going to an Apple store or a Google Play Store. And again, we need that in AI and radiology. We want one platform where multiple applications can be made available and that can integrate into the radiologist's workflow. The moment that happens, we will see far better adoption of AI into the radiology practice. Coming to the lab, it's a great source for radiology. Pattern recognition has been around in laboratory medicine for the longest time. The automation that we've put in our lab, both hardware as well as software automation, has brought down 27 manual unproductive tasks that our technicians and pathologists were performing now just to 3 manual steps. The remaining 24 are all performed by the automated hardware and the middleware AI software that we've got into our lab. The middleware AI software also enables us to auto-validate about 70% of results in our laboratory. So previously, we had 3 levels of authentication, one at the department level, one at a senior technician level, and one finally at the pathologist level. Now, when we look at any large, high-volume lab, and if you're going to have 3 levels of authentication for each and every test that is being performed in the lab, that significantly affects turnaround time as well as quality because there's user fatigue that comes into play as well.
Yep.
With the adoption of middleware and AI, we're now able to release 70% of results to the final level of authentication directly to the pathologist. And of those, 50% of those, so about 35% of the total pool, directly to the patient, where the pathologist also does not release a result. It goes, all 3 levels are auto-validated. So I think, with robust validation of the algorithms that are coming into the radiology space, that's something that we can look at within radiology as well. My final point with the role of AI in radiology and medicine and wider diagnostic medicine is to see whether we can use deep learning and Professor Amit Sethi can probably chime in here, is whether we can use deep learning to integrate multiple disciplines of diagnostic medicine. So that's laboratory, that's radiology, and now genomics. We all keep hearing about precision medicine, it's fancy word, buzzword, personalized medicine. How one patient should be treated will be different from how another patient is treated because there are a variety of factors that will affect the management of that patient for the same disease. So can we use AI to integrate information from all of these disciplines of diagnostic medicine and create personalized treatment plans that would be relevant to that particular individual only? There's a company in the US called Human Longevity Inc. Maybe you guys can Google it, take a look. They're doing some very interesting stuff on that front, integrating whole body MRIs, genomic data, lab data, CT calcium scoring, and so on, to provide a comprehensive health assessment of an individual. So that would be the long-term goal. But in the short term, some of the areas that Dr. Mahajan mentioned would certainly be on my wish list as well.
Great. No, thank you, Rahil. That's I think amazing wish list for Dr. Amit Kharat to kind of act on. It's very simple, sir. It's just you need a common platform, you need structured reporting, you need quantitative medicine, you need suggestions, you need Carpal, which is our platform, you need pattern recognition, auto validation, and then combine multiple disciplines. That's all we need. So Amit sir, where are things today? Like Dr. Amit Kharat sir, where are things today? As a radiologist building AI algorithms, what does the process look like from your perspective? And then, what are some examples of successfully deploying AI, either from your experience? I know a lot of the work you do is sometimes confidential, so whatever you can share. I'm sure all of us would like to know that from this wish list, what is possible today, and especially your perspective as a clinician trying to do all of this would be very interesting to hear, sir.
Great. Thanks, Vidur. Thanks, all the panelists. Really valuable suggestions for coming from everywhere and looking at most of it. Really nice to interact with everyone on this platform. It's a very valid point. Sir is there. Sir is the Chief Annotation Officer. I think that's an amazing title, and not only because it's one of the most crucial title and the position in any radiology AI company. And having a person who's of the nature of Sir and what Sir can do is the capabilities I can really understand. I think that is the heart and core of any AI company working in the space of radiology, whether it's X-ray, CT, MR, PET, ultrasound. The most important task is about data annotation, and that is, as we know the adage, I think it's been talked quite frequently in the space of AI, that garbage in and garbage out. We know it very well. It all depends upon what kind of data is being used to train your models. And everything boils down to that last point. And when we at Deep Tech look at the solutions, whether it is for the X-ray chest or the knee, spine, or the CT scans, the idea is basically it starts with envisioning the problem statement, what we are solving. Point number two comes to whether what we are solving is really going to help. Is it going to help hospitals? Is it going to help imaging clinics? It is going to help standalone X-ray clinics? Is it going to help society? Where are we looking at? What is the problem and where we are actually looking at? We try to look at a universal problem which could be solved, which could be having a lot of feature list, which could look into many. That is, we could target a lot of other aspects as well. A lot of kind of problems could be solved with one simple solution. Once we have identified the problem, let's say it's a lung nodule or a lung cancer or maybe tuberculosis or maybe a COVID screening tool, what we need to do basically is to work on the ground truths which are available. What kind of ground truths are available? Are there radiologist validated reports? Are there actually a correlation with RT-PCR as well? Or do you have some other tests which have been used, like a CT scan? And once you do that, the most important crucial process starts is about the data collation, what we call as the storing them in proper segments where you can have cases which are really accurate, those which are likely to be that particular pathology, and those which are unlikely or which will have other differentials. Then the next process comes is data annotation, and at Deep Tech what we do is we have a team of annotation experts sitting all across who are going to annotate this data using a lot of various tools which are available to do so. Now, this is the most important process, crucial component, and how we do the data annotation is going to ultimately affect or impact the way the algorithm finally looks and feels. Once this data annotation work is done, it is actually the job of the data science experts to look at these annotations and run through existing models or tweak models and give us the results. Again, it's a team of radiologists, not one or two, but independent sets of radiologists who are going to look at the same data set and confirm whatever finding has been picked up and what exactly is the sensitivity, specificity area under curve, your F1 scores and everything, confidence intervals, to understand whether that particular imaging and that AI has matched. And once that happens, then there's a lot of deliberation before this particular tool could be put on a platform. And once it goes on the platform, then it goes actually live. And once it goes live, it could be used in practice. Now, the way I see is that it's a very long journey. The way AI companies have to do this, it's a very painful journey, and it's a long process to get even the certification processes as well. The way we are looking at Deep Tech is we are supporting a lot of centers through our AI tool by using AI as a virtual imaging expert. So it is basically a supporting tool to radiologists and other imaging experts to help them facilitate faster reporting. So the way we look at AI is that it is an efficiency tool for imaging experts. The way we look at AI is that it is an augmenter for imaging experts, and as well as for physicians who are ultimately going to rely on these radiology reports. And that is why we call our tool the Augmento or the Augmento tool, because it is augmenting experts tenfold. The way we put it is that the AI outputs are going to generate those structured reports which Rahul was talking about, and that is something that we are already using. Moving to where it is being used, how it is being used. So the main theme is, we know the main goal for us at Deep Tech is to make healthcare universally acceptable and accessible. How we can make it affordable, accessible, and available, the three A's is what we are looking at. And the only way we can do it is that democratize the healthcare. Now, how do we democratize healthcare? Using these cutting edge technologies like artificial intelligence. And artificial intelligence, whether it's deep learning, which Dr. Professor Amit Sethi was talking about, is the one which is really making these significant impacts. Just to give you an example, we deployed this. So when we started Deep Tech, we started with just one tool that was for tuberculosis. And later on, we kind of moved ahead from normal abnormal to tuberculosis to granuloma nodule detection. And now we have 25 different pathologies that we can pick up from X-rays, right? From pleural effusion, consolidation, pneumonia, atelectasis, foreign bodies, cardiomegalies, hernias, and so on and so forth. So what now we do is we deployed it working very closely with the government, with the corporation. We deployed it, and it is currently live as well for the last 1 year. We have screened for 100,000 patients for tuberculosis. So that is one use case, and it is currently being upgraded to a tuberculosis plus COVID screening tool. Similarly, what we are doing is we have put it for 75 diagnostic centers and hospitals are using it live for their virtual radiology reporting. And I think that's the way teleradiology practice is the way in which we can increase and improve the reach of imaging experts. And as I said, this allows to use these solutions in practice to amplify and augment the experts. At the same time, give an output which is structured, which is consistent. So every physician who's looking at reports from various experts, the reports look the same. And of course, it has to be on a end-to-end workflow platform. And it's the end-to-end workflow platform where whatever questions Rahil raised in terms of prompt communication and notification to experts could be taken care of. And I think this brings the entire gamut, right from, to summarize, right from looking at a problem statement to actually commercially using a particular solution. But that's specifically for radiology as to way we look at it, and there are definitely different ways to look at the same problem. I think that's a small, short summary from my side towards the clinical validation aspect.
No, thank you, Amit sir, and very, very heartening to know that 75 facilities across the country or across the world are using AI in their day-to-day workflow. And then, as you mentioned, tuberculosis, COVID, they've really given a push. I think we can quickly jump into some of the questions. Actually, the first question that was asked. More of a comment, I hope the regulatory aspects also get covered. I think this is extremely, extremely pertinent, right? And during our discussion, yesterday, so for the benefit of the audience, we had a small discussion yesterday talking about, what we'll talk about today. We discussed this issue of ethics of AI. And it was a very interesting point that Dr. Amit Sethi brought about. And while we were discussing the ethics of using AI, he actually mentioned the ethics of not using AI, right? So I think he coming from a standpoint of are we depriving a patient of optimal care by not giving them available technology? So maybe we could spend a couple of minutes on that. Whoever on the panel wants to start, like, what are some of the ethical implications of using AI? How does one ethical, legal, regulatory implications of using AI today? And what is the path for somebody who either wants to use them or wants to sell AI solutions? Whoever wants to start.
Okay, so then maybe I'll start with a short summary.
Yes. Yes.
So definitely there are ethical considerations for using AI, right? So especially in medicine. It's not like AI is putting a dog filter on your face, and if the dog is off your face, then no big deal. You just change the app and go to another app. In medicine and in some other fields like self-driving cars, this has real life and death implications, right? So if AI says that this person doesn't have cancer and they miss actual cancer, then there is a real danger with that. So, like I was mentioning with that simplified example of predicting job success of students, in AI you would be predicting whether by looking at an image and clinical history whether the person has cancer or not, and then you can go into more precision diagnosis that is it luminal A type cancer or non or basal type cancer, and based on that you would prescribe treatment. So that is the hope. But then there will be errors. AI, we cannot take either of the two extreme views that AI can do everything correctly, or the other extreme view that AI will never be as good as humans. Both are wrong, in my opinion. So for very well focused, well structured data, AI is starting to do better than humans. But let me caveat that again by saying very well structured and very cleaned up data, right? So if you say that take pathology images from one lab and you train AI on it to spot cancer in lymph nodes, right? It will make fewer omissions compared to the needle in the haystack problem that a fatigued human expert sometimes might face, right? So that's where AI is doing better. But now you throw a slide at the AI which is out of context, right? So it is not a lymph node, or it's a lymph node with a hyperplasia, and it's not normal, but it is not cancer either. Then AI will be forced to make a decision on a subject that it is not trained on a context it is not
Yep.
trained on, and that's where the issue is. So unlike human decision making, where we can look at whether there was malice involved, whether there was lack of training involved, the certification was failed, and so forth, we don't have clear cut guidelines for AI just yet, but those are evolving now. So, but we have to start treating it in the same way, that was this AI algorithm. So there are different stages of AI, right? So you define the problem, you collect the data, you train on the data, you validate, and then you test, and then you deploy. So at each stage, we have to make someone responsible for that process and also for documenting that process. That this data, we trained it on Caucasian images, we didn't train them on Indian images, right? So that documentation at each stage of AI has to be done, and then we can start to even deal with the issue of someone. Can I request someone to mute themselves? There's some background noise. All right, thank you. Yeah. So once we divide this into the whole life cycle of AI and make someone responsible for documenting it and doing it with the due diligence that is expected for a life and death decision, then we can start to talk about ethics of AI. And there also we have to keep in mind that what the last part should not be missed, which is audit of AI. We think that once it is deployed, the thing is out there. Like a car, once it is sold, the car company doesn't know how the car is being used, except for exceptions like Tesla, which is connected. Car company doesn't know how it is being used. They don't know, what things are failing unless there's a mass incident, and then they do a recall. That is not how AI should be treated. AI is inherently much more amenable to connectivity. So there should be constant monitoring of AI, and then you can resolve disputes such as, did the maker of AI clearly indicate where it can be used, but the user of AI used it outside the context,
So,
or the other way
Amit
around?
sir, I'll
Yeah,
I'll just I would love to bring in Rahil and
sure.
between Dr. Mahajan and Amit at this point. So this whole responsibility issue is often widely discussed, and maybe it's very technical, but still would love your thoughts, Rahil. Rahil, if one of the lab medicine machines fails and starts giving out wrong results, who's at fault? Is it the pathologist? Is it the lab? Is it the equipment vendor? Or is it no one?
Well, I think one of the nice things with lab is there are a lot of QC checks built in, and the moment you start getting erroneous results, they will get flagged. So it's very unlikely that, even with the auto validation protocols and so on that are in place, it's very unlikely that you will have results go out erroneously, or if they have, then the user has missed those error flags or the quality check flags. And in that situation, then sure, the lab as well as the user has to take responsibility. It's no different, Vidur, from a wrong report issued for an ultrasound or an MRI, right? Who takes the responsibility, right? Is it the radiologist? Is it the center? Is it the management? So unfortunately, I think we don't have clear answers to those problems. In India, it's probably always going to eventually come to at the organization level rather than the user level. And now when we add in technology into play, where technology is doing this work, at the end of the day, the patient is going to say, I came and trusted your brand, I came and trusted your facility. So you are responsible for responsible use.
Because, in the world of self-driving cars, Dr. Amit brought it up. There are two schools of thought. One is the Tesla school of thought, which says that, the driver is always supposed to hold on to the steering wheel, even in autopilot.
Right.
And, the responsibility lies with the driver. Whereas then there's the Google and the Waze approach, which says that, we will not even put a steering wheel in the car. So, that's the analogy. Yeah.
So let me add my two bits. One, I think it's very important that when claims about the accuracy, the sensitivity, specificity of any algorithm are made, that's where the ethics conundrum starts. Because you would have seen even in this COVID era, I mean, it's been hardly 6 months, but probably thousands of algorithms have been made from all parts of the world, from small little towns in our country, claiming 99.9% accuracy, and newspaper headlines proclaiming to the world that's how it is. So I think ethics starts right from the developer itself and the development process and the claims made. And so it's this kind of exaggerated claims that are made that may actually lead to the demise of AI in medical use, because it's so very important to be cautious, to be careful. And that's where I think there has to be a huge emphasis on validation of AI algorithms. And that is something which I said, right in the beginning, because what may be 90% accurate in one hospital may be 50% accurate in another, and the variables are so many. And if the variables are so many in imaging, where still you have some standards, you can just think of the variables which would be in other fields of medicine. So that's number one. Validation has to be absolutely robust. And irrespective of the disclaimers that you may put at the bottom of the report, the guy who signs the report and the the letterhead of the institution are those who are responsible. You may, you will never be able to blame a pathology or a biochemistry manufacturer of equipment if you didn't use it well, or you used it for a different purpose. So I think to make this acceptable in a proper manner, it has to be, we do need to keep a control of the steering wheel, but even the guys making the car or the steering wheel have to be absolutely certain that in different terrains that they actually give the car for use, it does work. And or the more so in the medical field, where a little plus minus can make all the difference. And,
So
and then
I
who
think
claims,
the
who
key
claims
key
responsibility?
aspect there is of validation, and then also claim balancing or laying boundaries of operating, right? So the analogy I typically use is the fact that nobody really complains that an MRI is very bad for imaging the lung, right? Because everyone knows that an MRI should not be used for imaging the lung. So I guess AI would need to have similar boundaries and in place. I think the next question I can address to Dr. Kharat, and as I had mentioned at the start of the this webinar, that we will be going over by 10-15 minutes, so all the viewers can hang around and ask questions. This is a question from Balaji Ganeshan, and he asks, how does one qualify the different AI algorithms? Biological correlates on top of clinical and technical validation, and clinical utility are key aspects, and so are peer-reviewed publications. It's important to unravel the black box so the algorithm is intuitive. So, Dr. Kharat, as somebody who's constantly striving to prove the validity of one's algorithm, how do you think of this? The whole technical validation, clinical utility, and also the whole explainability aspect. And also, if you could just spread a little light on what exactly explainability and black box means. Would be
Got it. Right. Vidur, this is one of the most important, and this is directly linked to the ethics of AI. And the way we look at it is, as I said, when we started the lecture, what presentation was, we are looking at the ground truths. And as I said, the system will be as good as the ground truth that on which it has been trained.
What is ground truth? What is ground truth, Dr. Kharat?
Right. So let's take an example for maybe a lung nodule or maybe a lung cancer, and we are kind of developing an algorithm for that. What kind of tumor it is, and that's where the genomics of the tumor comes in. So basically, we can either have a broad level classification that it is a lung tumor, or we can go into a deeper level classification that it's an adenocarcinoma or a squamous cell carcinoma, and further it could be a non-small cell carcinoma. So all these are the subdivisions of looking at a particular tumor. And it's, let's say, a simple examination, not also a CT, just look at an X-ray. Now, if you're looking at a lung tumor very broadly, it's a tumor. A hamartoma in the lung is also a tumor. A large mass over a particular size is also a tumor. Now, how do you look to solve this problem? First is, when we look at AI as a problem, we look at a very broad level. I think when we start looking at a very narrow level, whether this particular tumor is a non-small cell lung carcinoma, then we have a challenge. So the way we tackle is, hey, is it a lung tumor? Number one. Second is, if it's a lung tumor, is it a benign or it is malignant? That could be the second level of a problem that it could be solved. And then the third level of problem could be, hey, this particular pattern of a lung tumor definitely fits because of its location for a non-small cell lung carcinoma or a squamous cell carcinoma. And how does that information correlates with other information? For example, history of smoking, was the patient having tuberculosis, there was a lung scar? Will that information also add to the diagnosis of that lung tumor and give a predictive analysis that this is probably a squamous cell carcinoma and not adenocarcinoma? And that is the ground truth. So the way we look at solving the problem is go step by step. Don't rush into it. Go on a very broad level, get a bird's eye view, and then put a second level to it. For example, not only diagnose, maybe you quantify it. And the third is maybe you do a progress monitoring. And as you collect more information about it, you go a step deeper and still let's talk about, hey, this is a non-small cell because we have seen now hundreds of them. So this pattern, this feature, this particular RIS information or clinical documentation is fitting for a non-small cell. And that is the predictive analysis which is going to come in the AIs of the future. And of course, there are a lot of groups at the moment who are looking at these narrow problems and solving this. For example, Sir just said multiple sclerosis. So there are people who are solving very narrow problems. There was a recent paper about glenoid bone loss where AI is being used. So I believe that there will be narrow AI solutions which could be solved at the same time a very broad level. And everything depends upon the ground truth. And the way we look at these black boxes is that I understand that the explanation given through AI solutions may be a bit as to how it reached that particular diagnosis. And that's a crucial component. And that's something which only a period of time will be able to get answers. We understand that's where the dilemma is, and that we believe that training of data set could be a big problem.
Yeah.
We need that variety, the heterogeneity in the data to get a confidence that it is not drifting. The drift is a very big challenge which can happen on AI. How we can prevent that by training it on a heterogeneous data set which is not only from one particular area or a geography, is that something which will be extremely important thing. So that's why we at the current moment believe that using AI the way we are using, where it is augmenting an expert, not replacing an expert in any way. It is augmenting him 10 times, 5 times by giving him an AI output which he can use to create a semi-automated report, which can ultimately lead to a final report. And whatever feedback the imaging expert gives is used to retrain the model. I think that's the way probably the things will go for the next few years before automation converts to autonomous. I think that's the way
Got
the
it.
journey is
Got
going.
it. No, that's a great way to put it, automation converting to autonomous. I will steal that shamelessly, Dr. Harsh. So next question I think is best answered by Rahil. This is we have international audience here as well. So this is Kabir Mahajan. I think I know him from Spain. Does it matter to the hospital management or the end user what is the technology that they're using, as long as it's solving their problem? So Rahil, I guess the question is more about, does it matter to you whether it's AI or BI or CI, or as long as it solves your problem, you're fine with it?
No, it doesn't. But at the same time, like I said, to get user adoption, it
Hey,
must
Rahil,
be some.
was I audible? Sorry.
Yes. Um, are you able to hear me?
Yeah, we can hear you. We can hear you.
So,
Yeah.
so Vidhu, to answer your question, it doesn't really matter in principle. But the point is that because of the user adoption challenges that I mentioned, if it's something that's completely alien to the radiologist, that adoption curve becomes that much more harder. So really, more than the type of technology or the type of solution that's being offered, what's more important to us and for us to see a faster pickup is how easy it is to bring into current practice without major disruptions.
Yep.
Okay, so there's always a two-step user adoption challenge that we see. The first is suspicion of technology that this won't work, and the second is if it works too well, then there is a fear that now I'm not required here as much before, or I'm not as relevant to this practice as I used to be before. So addressing both these points really is a greater concern than what type of technology per se you end up implementing.
Got it. Got it. So, yeah, just browsing through the questions here. I think another question from Kabir, and maybe best answered by maybe Amit sir, is would you validate AI systems fundamentally in a different way than some of the other traditional technologies? If you could shed some technical light on, well, we know the answer is probably yes, but would love your thoughts on this, Amit sir.
Which Amit? Okay,
Sethi, sorry.
maybe I'll start. So depends on what you mean by validate, right? So validation, if you mean by validation that rigorous statistical analysis of results, thinking through all the biases that the technology has, that the technology can handle, and how it was what it was built for, then yes. But most technology which is not mission critical for life and death is not validated in that much rigorous a way, right? So so basically think of it this way, right? If this technology was one day going to be used on your relative, how much rigor would you want to put in validating it? So if you answer from that
Hmm.
perspective, then you would bring all your guns of validation from statistics, from ethics, from thinking through more creatively, more broadly about biases and about out of label use case and so forth into the picture to do the validation and to build the warnings and to build the checks for different points like Rahil mentioned, right? So
Yeah.
these technologies for validation already exist. They are not like super new. Like there are maybe
Yeah.
some small innovations that are happening in validation. It's just about bringing the right mix of validation technologies. Again, to
Yeah.
answer, that your relative's life would one day depend on that.
Yeah. Yeah. No, I think we can keep talking about this stuff, but I think we have another 4-5 minutes to close. Maybe one sec. One question's just come in. Assuming the right level of validation, what is the key challenge for practitioners in consuming the AI-based solutions? from their workflow perspective. This is from Kedar. Anyone who wants to quickly answer this?
Right. I can take this.
Yeah, yeah.
Right. So I think that's the most crucial. I think everyone here is talking about using AI for medical image analysis, but very few are talking about using AI for workflow. When you are looking for extremely large workflows, I think AI can do a amazing job in doing the right workflow assignments, into looking into all the data analytics and give a lot of interesting insights. And I think that's one area which has been a focus area for us. So it's not only about medical image level analysis, it's about using it in your workflows so that you streamline it across imaging experts. Just to give you a scenario, you have MSK experts, you have body experts, you have joint neuro, and then probably you have subspecialty trained radiologists in CT scans, and then we have those who are doing only X-rays, and they are available at specific time zones across various geographies. How are you going to look at this large problem? This cannot be done at a manual level. This cannot be done by a single person or a group of individuals. There will always be a level of time zones lapses which are going to happen. We have seen that in our practices day in and out, day out. The only way to change that is by incorporating all these AI into workflow, where auto assignments of studies to experts to ensure quality review. So ensuring where there are likely to be potential issues likely to happen, and that's the most important area where we need to really put our attention apart from medical level image analysis, where already AI is showing interesting results.
Yeah.
See,
Got
if
it.
I may
No,
take that a little,
yeah.
if I may take that a little further, as a radiologist and as a practicing radiologist, what I want is the tool should help me in a manner which doesn't disrupt the way I've been used to working. That would be, the end point which every radiologist would have. I have a certain way, I have a workstation, there's a certain software on it. This needs to seamlessly integrate into my working. If that happens, I will gladly accept it. I will gladly use it. And maybe I will learn a little as I go along. It's not that, I knew all about it, but it should conform to my way of working. And around the globe, most radiologists have been used to a certain way of working, which is pretty constant, pretty uniform. And if the best AI tool may come, but if it kind of disrupts my working, that's going to be a problem. Number one. Number two, there are going to be many, many algorithms for different diseases that are being developed, and that will be available for use. And so I do not want that every algorithm comes with its own platform, with its own dabba. It'll just be too unwieldy. It'll not happen. So all algorithms, irrespective of whether Amit has made it, or IIT has made it, or Caring has made it, or anyone else has made it, they should be able to get housed on a single platform, which I'm used to, and through that it should integrate. That is the wish list. That is what we started with about 2.5 years ago with this wish list. And if that happens, then adoption of AI technology will be much quicker, much easier, and radiologists would welcome it. Of course, it has to be robust and it has to be accurate.
Yeah. Oh, great. Thank you. And maybe as closing thoughts, I see questions pouring in. Maybe there's one question around what is the time horizon for AI to be used in day-to-day practice in neuroimaging in MR, and after how many years will we be seeing it in practice in India? So that's the $1 trillion question maybe right now.
So if I
With
may
this whole,
say, I may say that probably India will use it first and the world will follow, because there's a lot of work going on here, a lot of youngsters building robust stuff, and AI for brain MR, I think, is something that'll happen, that is already there, but robust technology which can be used on a day-to-day basis, that should happen probably within the next 6 months to a year. And once we adopt it and it seemed to be useful, then probably the world will follow very quickly.
So I think, I'll just take now closing thoughts, as much as we can. There's some very interesting questions coming in, but, we can have a discussion on that question, which can span hours. But we'll quickly, I request, all of you, maybe starting with Rahil, or maybe starting with Joy, sir, since we started with him. Joy Chakrabarti, sir, are you still there? Yes, great. So what would be your 30 seconds to 1 minute of advice to people running hospitals today? What can they do? What should they be prepared for? To be able to successfully leverage on the benefits of AI. Your closing thoughts on the same, and then we'll just go around the virtual table.
So first, I want to compliment Vidur. It was an excellent panel, and the kind of things I was hearing for last a little more than an hour, and it was quite, in knowledge what I have gathered from all of you. So if you ask me, and we have been exposed to this environment and getting a lot of these AI-based tools are coming to us that you use. So first thing for a hospital, what we look for that we are getting into a deal, we are getting into a selection of a AI tool which is safe, secured, and give the deserving result. Someone raised a question in the question box, and you are telling that who is responsible, whether it is management or whether it is the doctor. So I want to tell that on any circumstances, as on today, the management will have the liability even after if it is put on to the consultant or the expert. So keeping that in the mind, we need to be very careful. We need to be very rational that what is the output we are looking out of this tool. It should not happen. We expect no sky or the moon to happen, but at the same time, we need to progressively take steps and see that it is giving us something better than what we are today. And two things in terms of management words we use: efficiency and effectiveness. So the tool, the technology, what we select, both these aspects needs to be covered by them. And if that happens, then definitely any management, anyone will come forward to adopt it.
Great, great. Rahil, I'll move to you next. As somebody who runs a chain of diagnostic centers, what should people in your position be prepared for? What action can they take to, get ready for this incoming revolution, if I may?
Yeah, I think two things, Vidur. One, certainly all diagnostic chains should get their data collection strategy in place because, as we've heard today repeatedly, that data is going to be of immense use going forward. So even when you bring in AI, if you have a ready-made set of data on which those algorithms can be applied and tested, that would be great. So that's one thing that people should start working on from now. And
Yep.
two, I think generally keep an open mind. There are lots of companies that are interested in partnering, working with you, even if it doesn't make, even if there's no financial gain from it today, that doesn't matter. It's something new, something revolutionary that's going to come into the way radiology is practiced. So keep an open mind, partner with companies that want to validate their algorithms, and I think, as Joy said, also be cautious before you take it live, because the last thing you want is to for it to boomerang and then suddenly you go back, substantially instead of moving forward.
Yeah. Got it. So store your data and keep an open mind. Dr. Amit Sethi, from your perspective, right? People who are building algorithms and who are who want others to use their algorithms, what should they keep in mind? Quick 30 seconds.
Yeah, so those who are building algorithms, they also need to have an open mind and be cognizant of the concerns and aspirations of the people whom they hope to get into a deal with to sell their algorithms or to sell their services. They should be aware of the kind of pressures that are on them about liability, the pressures that are on them about uh, at least some bit of explainability, and try to build that into the algorithm or the suite of algorithms so that that comfort can be increased, because ultimately a good algorithm in a lab is no good unless it goes out of the lab into the clinic,
Yes.
at least one day. Yeah.
Got it. Got it. Dr. Kharat, your thoughts, radiologists wanting to get involved in AI, what can they do? In fact, we had a question also on that. What steps can they take?
Right. I think that the interest among radiologists is fairly increasing from the time that when things started, and there was a little bit of a feeling of threat, but now the perception gradually is changing to acceptance. I think we have to go with open arms and embrace it, because this technology is going to, as Sir rightly said, Mahajan Sir also rightly said, is it's going to be differentiating those who are using AI versus not, and those who are going to use are going to do less mistakes, are going to be more efficient, and will suffer less burnouts. So my 2 cents on this matter is like they should be very open and start experimenting, start publishing, and start interacting more with this technology, because it's here to stay.
Great. Dr. Mahajan, your closing thoughts.
See, I like to quote a very legendary figure, Jack Welch. He was the chairman of GE Healthcare. And one of the things he said is change before you have to. So this is advice for radiologists. This is advice even for diagnostic chains, hospitals, that this is something that's coming. And the earlier we adopt it, and the earlier we mold the way we work to the incoming AI, the better it'll be. And I sincerely feel that radiologists with AI will replace radiologists who do not adopt AI. That's my 2 cents.
Great. No, thank you so much, everyone. I typically refrain from citing my opinion whenever I'm made moderator, but I think the change before you have to idea applies very much to doctors, to healthcare providers, but also to algorithm developers. Because so we have this saying, at least at Caring, that you can't build solutions for hospitals outside of a hospital. So my 2 cents to everybody who's building AI out there, like if you are not sitting with your users and building AI systems, it'll be very, very difficult, and your time to market can become much longer. But yeah, that was just my 2 cents. So thank you, everyone. Thank you, CII. Thank you, Medikabazaar, for organizing this. Thanks, Dr. Mahajan, Dr. Kharat, Dr. Sethi, Rahil, Joy, sir. Thank you, everyone. And hope to see you guys soon in person someday.
Thank you. Great panel.
Bye.
Thank you.
Bye.
Thank you.
Thank you so much. Bye.
Bye.